read number 23 for us, please. Read nice and loud. Matt, could you turn the volume up?
I don't have a book. Let's see how many times you can say my name.
Yeah, ready.
Okay. What is n if n p to the second is 72?
All right, so we got n, thank you, Matt. P2 is 72. We want to find n. And Jessica, you said it right. We did not go over this yet. But NP2,
Hey, Mom.
forgive him, Mom. It's going to be n factorial over, who can tell me over what?
N minus P.
Excellent. N minus 2 factorial. Write it down.
What?
Summation.
You just told me.
N minus 2 factorial. That is 72.
I've never seen it. I
Oh,
don't like my voice on recording.
yeah, Jake, looks like you're ready to sing a solo for us right now.
Okay.
All right, but that's all this means. NP2, if this were 7P2, it would be 7 factorial over 7 minus 2 factorial. So we want to find n, and here's the way of finding it. Some of you are writing it down, some are not. Write it down, Jesse. All right, n factorial is nothing more than n times 1 less than n would be what? N minus 1. What's the next one? N minus 2. All right, and so on. And because I don't want to keep writing, I can say n minus 2 factorial right there. And downstairs, I have n minus 2 factorial. That's equal to 72. And watch how easy this will be now. We're going to cancel all of these, n minus 2, then we'd cancel everything, n minus 3, and so on. Going to cancel with that. And the only thing that survives would be what? All right, so let's write that. N times n minus 1. And that's going to be equal to 72. And we should be able to figure that out. Let's distribute. So it would be n times n is what?
N squared.
N squared minus
1n.
1n, or n equals 72. You might say, well, how am I going to find out n then? Yeah, we factor. We bring the 72 over to this side, so we subtract 72 from both sides. So we have n squared minus n minus 72 equals what? Equals 0. And then we do a little bit of algebra 1 factoring here. Let me see if anybody remembers how to factor something like this.
You find the lot.
It's going to be n times n, correct? N times n. How can we get negative 72 by multiplying two numbers together? One has to be positive, one has to be negative, right? 9 and 8. And which one should be negative, the 9 or the 8? The 9, because this, yeah, because the bigger one will dominate the middle sign here. So it's going to be minus 9 here, or you could put it in the other parentheses, and then plus 8, like that. And we got one step left to finish this off. Let's go over here, finishing it up. So when we multiply two things together to get 0, either the first one has to be 0 or the second one has to be 0. Because 0 times anything is 0. So either n minus 9 has to be 0, or what? N plus 8 has to be 0. Can we solve this?
Yes.
Yes. Add 9 to both sides. So n equals 9. Yes, I heard it. I heard it, Jessica, loud and clear. N equals 9, or what? Subtract 8. Negative 8. N equals negative 8. So I wonder who could tell me why I'd have to choose 9 for the answer, not negative 8. Yeah, we got to use a positive. And so usually when we're doing factorials and so on, we don't use negative numbers. So we'd have to discount that one and use a positive number. Anybody follow that?
Answer's 9.
The answer n equals 9. Saul, you follow that? All right. Any quick questions on this before we go to the other one? Yes.
How do you get n minus 1 times n minus 2?
All right, good question. How do we get this right in here? Let's say if n were, I'll just make up a number. If n were 9, then this would have to be 9 factorial would be 9 times 8, which is 9 minus 1, right? Times 9 minus 2, which is 7, and so on. So that's the idea here. But
So-
n is just any number.
So it's always gonna be minus 1, minus 2.
Yeah. Kind of like a countdown. 9, 8, 7, 6, 5.
Okay.
Not yet. All right, let me go ahead and take you into, well, let's look at the other one with me, because some people didn't do it. Number 24. Jessica, read that for me, please. Number 24. What are we looking at?
Find the values of 10C4 and 10C6. What do you notice?
All right, NC4, 10C4, thank you. 10C4,
And 10C6.
10C6. And a number of people got this and they found out that it's quite interesting. All right, 10C4. So what is that? What is that in terms of numbers?
I like the whole idea too.
Thank you. Like my answer?
No, what does it mean in terms of setup? 10 factorial over 10 minus 4 factorial times 4 factorial. Yeah, some people did nicely on this on their test.
What?
All right, this one right here now, 10C6. Jesse?
10C6, you would do
10 factorial over
10 minus 6
10 minus 6,
Figure so many of these on the times.
6 factorial. I'm going to show you an easy way to work this out. Some of you probably already know. All right, look carefully with me. This is going to be 10 factorial in the numerator over 10 minus 4 is 6 factorial, and downstairs will be 4 factorial. Let's just work it out like this. 10 factorial is 10 times what? 9 times? 8 times? 7 times? 6. I want to stop it right there because I've got 6 factorial here, which will cancel this whole thing, all the rest going down. Over 6 factorial times 4 factorial. This 6 factorial will cancel this 6 factorial because this is 6 times 5 times 4. It's going to cancel this completely. And this 4 factorial, we can actually cancel it. Anybody, any of you worked out with your calculator, maybe we could do it that way. But anyway, if you want to work, this will be 4 times 3. Let me see, 4 times 3 times 2 times 1. If you don't have a calculator, you could still do it. 4 times 2 is 8. That would cancel with this. And then 3 would cancel what? 3 would cancel a 9, 3. And that would leave me 3 times 9 is 27. 27 times 10 is? That's not right. 7 times 3 is 21. 21 times 10 is 210. Sorry. 210 for this one. And over here, I'm going to do 10 times 9 times 8 times 7 times 6 factorial like that. And down here, we're going to have 10 take away 4 is 10 take away 6 is 4 factorial. And then times 6 factorial. This will knock this out. We're going to be left with the same thing here as we had right here, right? Exactly the same thing. See it? Honestly, I only got 210 twice. 210 twice? Okay. I just want you to see. So, for example, if we have now 10C3 compared with 10C7, can you see that those would be the same? No, they would be the same. Exactly the same. All right. Huh?
That's fine.
Yeah. All right.
All right.
Let's go to our new lesson. I'm going to take you about.
Whoa.
Let's review.
No.
Jake.
Close.
I know. But this is going to be. All right. Look carefully now. This is some review. Let's go ahead and review something.
This is not good.
It is very, very good. Didn't get it?
Didn't get it.
Let's try this. All right, let's go ahead and review. This is called, in your notes now, simplifying radicals. I'm going to have somebody write on this for a while too.
Oh, can I?
So the first number.
Yeah, maybe I'll have you do the first one. Simplifying. Write this down. Simplifying radicals. Write that down in your notes. All right. So let's take an example. Jake, you ready?
Yeah.
Let me see if I can put one up here. Yeah, this one is. Now here it is. Simplify. Square root of 32. This is not calculator work. Now, do you remember how to do that?
Yeah.
Let me see if he's. All right, go ahead. Jake is going to try this one. Simplifying square root of 32.
Oh, that's easy.
Oh,
I know it's kind of weird. You have to look up a bit.
nice, Jake. You got it.
I just gotta think for a second, alright?
Give him a chance.
This sharpening is straight side.
Nice.
There you go, Dank.
He nailed it.
Oh, I knew.
Any of you remember that?
Ready?
All right, let's go over it. Remember
Dank
well.
got it. I remember.
Stop!
Yep.
All right, it's gonna be 4 root 2.
Stop.
John H., you're blocking
The view.
the visibility here. All right, two ways of doing this. One of them you can do it fast like Jake did, where you think of 2 factors of 32. Listen, John H.
That's the only
Sorry,
one.
coach.
We're not ask your dad to listen to this.
No, I'm good.
Hey, John just said.
My dad.
Can you post this to the Moto?
I am
Hey,
gonna
Mr.
post it.
Fernandez.
2 factors of 32, such that 1 is a perfect square. Jake was able to think of 16 as a perfect square times 2. That's a fast way to do it.
We should make a
That's the only way.
podcast of all our classes.
Well, I'm glad you know that. But there's another way you could do the what is it called again? You could do factor tree. If you like. It takes a little time.
Yeah.
What do you do? 2 times what? 16?
Yeah.
And then 2 times what? 8. And then 2 times 4 and so on, all the way down. I think you got all prime factors. So you got 1, 2, 3, 4, 5 2s. Dan M. Don't throw missiles across the class.
What?
Missiles.
Missiles.
I didn't.
Are you?
I hope you're
You
hearing
got
this
5 of
page.
them. 1, 2,
Missiles.
3, 4, 5. And some of you might remember that wherever you see 2 of them, that's like the square root of 4. If you know what that would
This is
be.
hard. It's easy.
Again, square root of 4. And then finally, 2 by itself, there should be 4 sign. And then square root of 2 here. So we got 2 from this one. Emily, pay attention. 2 from this one. And then square root of 2 is left by itself. You pay attention. So 2 times 2 is 4. And the answer is, like Jake said, 4 square root of 2.
Let me do one.
All right, you want to do one?
He's
Let
not
me
ready.
see. This one's a big one. Oh, take a big one.
For a little match.
All right, let's try a big one. This is going to be simplify square root of 300. We're going to have somebody else come up with this one. Dan, it's kind of awkward,
That's even
right?
worse.
But yeah, Dan is going to do that one. Square root of 300.
He's ready.
Alright.
Oh, you. Can you start?
Do 100 times 3, Jane.
That's what I was gonna do.
Why are you a factor trade?
Why is that line? What are you doing?
Why?
Give him a chance. Give him a chance. Takes a little time to get the practice.
Yeah, it takes about 5 seconds.
There we go.
Look at this.
100 times 3. He's got it. 100
Why
is
do
a
you put
perfect
that-
square. He's got it.
You're a lick.
100 is a perfect
That's
square.
just normal handwriting, though. So it's not-
Yes, guys, chill out. Look at Joe.
What is that?
2 times 2.
Yeah, you couldn't have done 10 times 10.
No, bro. This is better.
You're doing factor tree, I think.
Yeah.
No one knows for sure.
So bad.
It's hard to write on this thing.
Yeah, it's awkward. It's not the same.
You don't use this every day like
That's
this,
how his
man.
handwriting always looks, though, Mr. Henry.
Here's Joe's.
They don't want to even be able to make it legible. All right, I think he's got all the prime factors now.
Alright, now,
What do you do?
well,
It's gonna be 5.
Who can help you? What
That's
do you
where
do now?
here's the answer.
Nick, what do you do?
It's 5 times 2 because you have the 2 5s and then 2 2s.
So you,
5 times 2 is 10 and it's square root of 3 because that's all you have left. 10 square root of 3. 10
Right.
square root of 3.
so wherever you have two of them, it comes out as one? Yeah.
Yes. Got 'em.
Yep, you got it. 10 root 3. Thank you. All right, I'm sure you follow that. In fact, what Jake was saying, you could have actually gotten it from here, right? Where you could have square root of 100 times square root of 3.
yeah, I'm not doing that.
Square root of 100 is what?
I was trying to
10,
do
you
it.
could have just written it
I was
from
trying to do
that.
it myself.
Or you could come down to wherever you see 2, that would be square root of 25, that would be a 5. And 2 2's together, that would be square root of 4, which is 2. And then the 3 stands by itself, so you leave it as is, like that. Right? So 10 root 3. Alright, I'm going to do one more and I'll give you some to practice.
Alright, I'll see this.
So much better. I'm going to give you a tough one though.
Alright.
Let me see. It's going to be tough now. You ready?
Alright.
Let me see. You can do it.
You want a magic? You want to come through something?
Big Sean.
No, this one is maybe too tough for you. I don't think you can do
Alright.
it. Alright, let me put it up so you can see. Alright, no more talking now. Pasha, I'd like you to listen passionately here. Pasha,
Jake's trying.
Jake, don't distract me.
Mr. Henry, come too.
Let me put this one up.
Like Big Sean?
Simplify. This one has a square root in it, Nick. I don't know if you're going to be able to handle this.
Alright.
Simplify. Let's say 32 over 3 times the square root of 2. Everybody remembers that from
Alright.
Mackenzie? Do you remember what to do this?
I'm ready.
I remember, I know.
I need a calculator.
No, not calculator.
I just.
Anybody remembers?
Yes. Which part?
Jake, you remember how to do this? This is a 3 square root of 2 downstairs.
Let me, can I write?
Yeah, you have to make it,
I'll write for you.
you make it turn into,
Do you multiply
36.
by
Or 12, I mean, you
square
make it
root
turn
two
into 12.
cancel out?
Mackenzie's got it.
Yeah, that's what I said.
Yeah. Listen, class.
They
We're going to
do it
multiply
here,
top and
18.
bottom by the square root of 2, and that will get rid of this. It's called rationalizing it.
Oh.
You remember how to do it?
I want to write, yeah.
Oh, can I
Okay.
do this
This is
instead?
why
Alright,
you're
let me do this one. Maybe I'll give you another one.
He's smiling too much, that's not good.
32 over 3 root 2,
Yes, you just.
top and bottom now, by the square root of 2 to get rid of the radical in the denominator here. Here we go. Essentially, we're multiplying by 1 because anything divided by itself is 1, so we're not changing the value of the expression, we're just making it to be in another form. So here we go, 32 upstairs times root 2. And downstairs we're going to have 3 square root of 2 times square root of 2. Anybody remember what that is? Square root of 2 times square root of 2, I heard it. Yes, same as the square root of 4, which is? 2. So here we go, 32 radical 2 over 3 times 2. And we can knock this down by reducing. That would be 16. Answer would be what? 16 root 2 over 3. Honestly, anybody remembers that?
Yeah, a little bit.
Yeah, somebody remembers. All right, just write that down now, and I'm gonna post this one so you can maybe review it.
We have to do a test.
All right, let me.
We need to check our stats.